In the last class on Monday, we looked into this slide, which describes what the mechatronic way of product design, correct, compared to conventional design. Already I told you the primary advantage of mechatronic design is nothing new, but we are trying to use computers for each and everything. Starting from mathematical modeling, then doing simulation, then optimizing each and every component, every system, electrical, mechanical, or control system, all those things in using computer optimization through simulation and modifying the system parameters or mathematical model. Then when everything works, then optimized design is there. Already told you, which is called as virtual model. Virtual model and virtual testing. Please note the virtual means physically no component, no electrical, no mechanical, nothing is there, but the entire machine has been designed, tested. Of course, you will use as a 3D on your 3D system or 2D system on your computer screen. And virtual testing is done. So if everything is satisfied, final design has come, then you will start testing, making individual system. That is what called hardware in loop. And another thing you come, this one nowadays come out, industry people will be talking of hardware in loop means I have the electronic control unit, ECU, correct? Then which is connected to the mechanical system. And this is put with lot of sensors, feedback sensors, which is going to measure feedback sensors. Machine is instrument of feedback sensors, which measures various parameters of the machine. So that is given as a input to the controller, and you give the reference input. Reference input, what should be engine speed, what should be torque, whatever, depending on type of machine you are going to give. So that is going to, this is the output, this is the input set point or reference input we give. So that means now you have the sensors are there, you have electronic control, mechanical, but machine is controlled by actuators. Right? So all these things already you designed and developed. Electric motor, what should be its power, what should be RPM, what should be torque, correct? How much current it should take. All this thing you are tested using model, correct? The actuator model you develop just like this one, using this method. Similarly, sensors also. For example, you want to measure the pressure sensor for the particular device. The pressure sensor you are model and tested and optimize the design. Sometimes you may need new sensor. Please note that sometimes you need to develop your own sensor. Or you can buy standard sensor, or can give the sensor design to sensor manufacturer for your specification for this machine. And so that means you need model of the sensor, all this thing, you have tested all this thing. Similarly, ECU, all this thing. Now everything is done, virtual model, virtual tested, you are satisfied. Now what you do is, next step, as we told in the previous class, you can make the ECU, the hardware. You can develop ECU software, control software using MATLAB, Simulink, like this one. And you can make mechanical components, test it physically. I'm talking of physical testing. You do one by one. As per design spec, the optimized design, you make physical component, physical prototyping, and test them. Again, individual component, assembled component, all these things. If there is some small failure or something, you can do little bit tweaking. That is sufficient. That is the advantage of the mechatronic design instead of conventional design. Yes, please.
Sir. Sir, you supposed to record, no, sir. You last class you recorded. Now you are recording it.
Because in between I'm just getting. I have a little cough in between every time, so I don't want to record. These things I will record separately. Thank you for reminding. Kind of it. Okay. Okay. So you gave it a feedback, and now you can make each and every component separately and test it. That is called physical prototyping. From virtual prototyping, physical prototyping, and testing. Physical testing. Of course, this time you are not going to change the component each and because already you are very close to what you want. What material, what should be dimensions, everything was already optimized using computer, which is faster and economical. And you make and maybe sometime minor tweaking or minor adjustment or maybe the small green design because of the material problem. You will not get, for example, you say stainless steel, SS, grade 10 something, I don't know. I'm not a mechanical engineer. That's what you wanted to use for making your connecting rod. Correct? In the SS 10, you wanted to buy, say, for a connecting rod like this, it has a diameter, you say that it is 10 centimeter, diameter is 2 centimeter, and the shape, I'm just approximate. It is a solid, this one, using SS10. Okay? SS10, theoretically, it has some, this one, Young's modulus, shear modulus, this much, all this, the mechanical property as per book. Correct? SS10 means this much percentage of Fe is 98%, 2% carbon is 2%, nickel some 1%, something like 97 something. This is composition called SS10, theoretical. But when you try to make, if you buy SS rod from a company, correct? X company, Y company, Z company, correct? So the SS10, even though they say it should have same this one properties, chemical, physical properties also, Young's model, everything, but it will not be there. There will be a slight variation, correct? Because making the SS10 as per the theoretical spec is impossible. Theoretically, everything you say, finally, they take hundreds of tons of coal, tens of tons of iron ore, melt it, remove this one unwanted material and add carbon, correct? In furnace, correct? Furnace is not going to do 1 kg, 2 kg. You are going to do hundreds, at least tens of tons. Each time this is melting all this thing, big furnace, industrial grade furnace. So in that case, you said that you should have 97% of Fe, correct? You wanted to have 2% carbon and one, say 0.5% nickel, something like that. You are adding, correct? 0.5% or 0.2% something. This material you are going to weigh, correct? 97% Fe, I am talking about around 10 ton or 20 ton furnace, correct? So coal you are going to add. All this thing, when you do that, it is exactly not possible, correct? Exactly, you will not be able to add 0.5 and purity of Fe, correct? Iron ore, purity of the carbon contents or purity of the nickel, all these things is not possible. You are trying to get as close as possible. That's why if I say that my length is 20 centimeter to 2 centimeter dia, and if it is made of SS10, it can withstand force of say 10 Newton force. That's what theoretical says. But if you make that, sometimes there may be defect in the physical material. Defect may not big mistake. The composition exactly no company can make. That's why if I say SS10 steel, if you buy from X company, they may say 40,000 per ton. For example, I'm saying Y company says 55,000. Another company says, Z company says 35,000. Correct? Why there's a price difference? There's not only profit margin. Correct? You say that the I bought these three companies tested. The particular company is doing well. Correct? So it is as per the standard. It takes this much and all those things close to theoretical value. So you try to buy that. Correct? So that is the making of the steel itself is very going to be tough. Correct? Exact as per the theoretical spec. So that means when you do from the theoretical model, optimized design, you are trying to make each and every this one. We need the mechanical system, physical system, mechanical system, then control software, which will be put inside the ECU, electronic hardware, and you have the sensor and you have the actuators, right? All this thing you have to make and connect everything so that they work as a complete system. These are sensors, give the feedback. This is my set point. This is the whole mechatronics, the automated, fully automated mechatronics system, automated system. That's why the mechatronic comes in. Mechatronic controlling the mechanical and electronics. When you want to do this, now from the virtual model, you can make each and everything separately. Control software develop the hardware, the actuator. For example, there's a motor, there's the electric motor, say 1 kilowatt power, 100 volts, all those things. You fabricate this. First prototype. Similarly, mechanical whole system you develop. Again, by make the sensor or this one. Now, if you try to integrate, then you get a physical prototype. This is one way. They call full physical prototype. Instead of that, what you can do is you start with the latest. This one is instead of making everything this one, even though this is optimized, I make one part first mechanical system alone. Right? mechanical system alone I make, remaining part will be still as a software running in the computer. Still, the many things are still as a virtual model. From that, get the output and apply to the physical system. I made mechanical system alone as a physical system. For example, you take the engine. Engine, correct? You can make the engine, physical engine, and you need sensors, actuate, all those things. Correct? Some part will be in the computer, some part will be in the system, and testing whether the engine is working properly. Correct? Instead of making complete this one. Again, we need to make ECU. ECU means you need to develop a separate hardware. Instead of that, what I was doing, the software, the ECU was, your computer was working as a ECU. Correct? When you are doing virtual prototyping, you never had a ECU with your microcontroller, all this thing. You are using your computer itself as a ECU where you are developing control algorithm. And you run your control algorithm using your computer's CPU, i7 plus i10, but you never develop the ECU. Now, while testing also, I developed the mechanical engine and put this actual injector, sensor, all those things. And still, I control the fuel injector and the spark plug, all those things from the computer. That means the engine is a real hardware. Engine is a real hardware, which but control system, the ECU, all those things are still as a virtual prototype only. That is called a hardware in loop testing. Correct? Next, now engine is working all right. Then what I do, I develop the ECU. Correct? I develop the ECU hardware. ECU hardware will be actual prototype hardware will be connected to this one. Now I develop the software. I put the software inside the ECU embedded controller and test it. Now already your engine was tested in actual physical prototype. If there is a small thing to be changed, the component or the engine component, all this thing will change. But the control algorithm ECU was still the computer only. Next stage, you develop the hardware and you test ECU hardware, real hardware with a real engine, but some part is still in the computer. Like that, you do section by section, correct? So testing that is called a hardware unit testing, correct? Advantage is, again, you are not going to waste any physical material. Testing with hardware and loop, that is, you make one system, physical prototype engine, and it will work close to, because already virtually designed, it is close to what you want. So if you make the physical prototype as per dimension given by the virtual prototype, because already this one, it will definitely work. May not go, for example, I say the 10 kilowatt power, 50 Newton, kilonewton, this one, say for something, correct? Maybe 10 Newton, kilonewton torque, and 0 to 3000 RPM, something like that if you are talking. And if you which was designed as per this one, when you do that, it makes it all 9.9 kilowatt only. Torque maybe, for example, 49 or 48 Newton meter. Correct? The RPM goes to 0 to, for example, 2800 or 2900 RPM only. This is not as per this one. So then you will modify the components, all this thing, dimension and fuel, this one. Then you make your engine. So that, so minor tweaking. So that the engine is now ready, which developed already. Physical prototype also you do minor changes, correct? Component change, this one. After that, the engine is now ready. Then you develop the ECU hardware. You selecting appropriate microcontroller plus other signal conditioner amplifier, all those things, the hardware and the software developed will be loaded in the embedded software, and the ECU is ready. That will be integrated with the physical engine. Correct? Like this, if you do stage by stage, then you will not waste hardware material. Correct? Physical prototype, I told you, main problem with conventional design is every time you have to take a new raw material, correct? Machine it, do it, make the machine. If there is some failure, again you have to redo. Correct? Again you do. That is reduced. So by using hardware in loop, you can test each component, physical development. If it is working, then take the next component, make the physical, integrate. So this is how doing. So this is the final design optimization, correct? So that will do mechanical system, embedded software development, and also the hardware like this. That's why the life cycle optimization, we call it life cycle optimization, will work. But when you try to integrate everything, still you may get minor problem. Individually system will work. correct? Another problem is many times individual system, engine will work, ECU will work, hardware, physical hardware, similarly software development will work. But when you integrate, again, there can be a minor discrepancy. That is why again you go back, correct? If needed, again you start with concept, you change the concept. Engine, you design with for inline cylinders, correct? It is giving you some vibration, something. Then somebody say V engine is better, correct? So again you may go back to also, correct? You change the design. At any stage you can go back. Please see here, the mechatronic design is again every time use computer. Even in the simulation itself, we are going iterative, correct? So you came from here, again you can looping, correct? Without making physical prototype. But you can do quickly. Then you do a hardware in loop testing. Again, then you go to the actual integrating everything. Then life cycle optimization. That's what you do. If you make a vehicle, new model of vehicle, your car company, motorcycle company, we are coming from, correct? You do all this, you test it in the road for 1 lakh kilometer, 50,000 kilometer, correct? Camouflage, all those things, correct? You test, then go high altitude testing, sea level testing, high temperature, low desert condition. You do for testing for 1 year before launching. That's what life cycle optimization. That time you'll see that whatever design was working in your proving grounds, correct? In test stock our company. But when you go to actual environment, in Chennai, sea level, Ooty, Kodaikanal, go to Himalaya, rugged roads, correct? Go to Rajasthan desert, all kind of this one, they call life cycle testing. That time also you have to modify small tweaking, correct? So this is how you are developing this, okay? So this we already know. Primary advantage of doing the mechatronic way of design compared to conventional design. Now that we are coming to end of the different, I wanted to give what is advantage of conventional design or traditional design of a mechanical product compared to mechatronic product. Please talk. You should be again clearly noted that the traditional machine doesn't have the electronics. No electronics. That means ECU nothing. No sensors. No electrical actuator, external actuators. Electrical or mainly electrical actuators. Right? Then no software. Because it's purely mechanical system, every part made and it is controlled by human. Correct? Like a or talk about 50 years before, 60 years in American, Japanese car, Toyota, whatever it may be, 50 years before, they called conventional pure mechanical automobile, right? So I am comparing with that the electronic latest generation car, what car, including Nano. Tata Nano is a low cost. It has a lot of it. It has a fuel injection system. It has steering as this one, and I think it has a assisted thing. I don't know whether it is ABS. The high-end model, it may be Tata Nano also, low cost also, a lot of electronic sensor control, right? So now all automobiles are mechatronic system. They are not no more traditional mechanical system. That is why you have to learn mechatronics as an automobile engineer. Correct? So what is the main comparative feature? Advantage, disadvantage. Note down the points, very important. Correct? So traditional design, the system is bulky. Correct? Traditional system, bulky, complex mechanism. Correct? Everything is, if I want to do anything, I have to add gears, links, joints, all those things. Correct? So even if I can do little automation, all those things, I can do it mechanically, adding more links, more gears, all those things. So my machine become bulkier. Correct? Still, it is manually controlled. It cannot do that. There's no non-adjustable movement cycle. You cannot adjust. So mechanically, you can adjust something, but you can, for example, you take a shock absorber. Correct? Shock absorber, you have a spring and there's a damper. Correct? If you take a motorcycle, there will be a step-like thing. Right? You can adjust the pre-tension, the spring tension. Correct? I call the stiffness, KS, can be adjusted. There will be a small lever like this. I can push it to different notches. Correct? So that the stiffness of the spring can be changed. If you see motorcycle in the shock absorber, you'll see this. By loosen this nut and move it to next nut, tighten. Correct? So while driving, correct? You know the suspension, I want to, depending upon road condition, the suspension stiffness should be varied. Spring stiffness. With a soft road, correct? And hard road and road with lot of this one, uneven road, then you need to adjust the stiffness. Then only it will absorb all this energy. Okay, that is possible if you adjust this spring stiffness. But while driving the vehicle, you cannot have a spanner, somebody sitting behind the seat while you are driving motorcycle, correct? As I read, your pillion rider cannot take a spanner and adjust the stiffness by moving the nut, correct? Mechanically, you have to move because depending on road condition, you can move it. Every time you have to move this, not possible. But instead of that, you have what you call as active suspension. Any of you know what is active suspension? Any idea?
It will adjust the stiffness of the suspension um, while the vehicle is in motion to give the best possible suspension feeling to the driver.
Yeah, that's correct. So that is the active suspension,
and it can be changed based on what kind of driving mode he wants, sports or comfort.
Yeah,
or
sports mode, rough road, or pleasant driving, highway, all these things you can select. But nowadays it does automatically. If you go to Rolls Royce, correct? Rolls Royce, all those things, if you see that, they have this kind of suspension. That's why it costs crores. One suspension costs more than 1.5 lakh, 2 lakhs. If suspension goes in Rolls Royce, you will spend 2 lakhs, one suspension. 4 suspension, that takes only 8 lakhs. What they use is what you call magnetorheological fluid. Magnetorheological fluid is used instead of, because you know that shock absorber contains two parts. One is a the damper, other one is a spring, correct? So together they form as a shock absorber in any vehicle. Okay, this damper is filled with, conventional damper is a piston moving inside a cylinder, both sides fully enclosed, which is filled with oil, correct? In the piston there are small orifices, but when the piston moves, the fluid from one chamber it goes to other chamber, which produce what you call damping force. We call it damping force. The damping force similarly spring as a stiffness. Stiffness, when a force is applied, getting compressed, this one, this opposition force, that we call spring force. The damping force and the spring force are responsible for absorbing the ground reaction force when vehicle is moving over an uneven surface, when road is not flat, correct? That absorbs so that passenger is not affected by the ground reaction force, what we call FG. That generates an acceleration, vertical acceleration. That vertical acceleration make your vehicle to move up. Vehicle is called a spring. Anyway, don't worry, we will talk about that. Correct? I will talk about the spring mass damper system that I will explain you. Correct? In active suspension, there will be a spring. There's a damper. In the damper, instead of regular oil, viscous oil filling, they fill with what you call magnetorheological fluid. Correct? The magnetorheological fluid, any fluid has a viscosity. Correct? The viscosity of any fluid is fixed. You cannot change it. But it varies with respect to the temperature of fluid is changed, it changes a little bit. But viscosity for a given fluid is fixed. But magnetorheological, by applying magnetic field, external magnetic field, you can increase the viscosity or decrease viscosity. How? By supplying a current, because I have the damper, correct? Damper as a piston moving inside a completely closed. This is filled with fluid. This fluid is MR, they call MR fluid, correct? In the piston, there are small holes will be there. When this piston is connected to the moving part, when moving part moves under the piston, because it is filled, completely filled with fluid. What fluid? Viscous fluid. You know the fluids are incompressible fluid. That means when piston were to go up, the fluid from here should come here. But similarly, when piston is going up, I call it A, this is B. The fluid in this should be come here through this hole. The rated fluid coming from chamber A to B, correct? Going to decide what rate the piston can move. So there's opposite, that is called damping force. The damping force is proportional to the hole size. They call orifice diameter D, and also the viscosity of the fluid which is filled in this one. Conventional damper, you have regular oil where viscosity is fixed. In MR damper, I will fill, instead of oil, I will fill with the MR fluid. Apart from that, above the damper, I have a magnet coil. I supply voltage to this coil. So there's a current flow. the coil produces magnetic flux. Okay, by varying the current flowing through the coil, I can change the magnetic flux. If I vary the magnetic flux, viscosity of the fluid, MR fluid changes. So the damping force FD changes. This is called as an active damper, correct? So the only thing is the MR fluid, 1 liter costs something around 50,000 rupees. Because I bought 1 liter, no, 78,000 I paid last year, but I'm working on MR damper. Correct. I work on damping, vibration, all these things also I have set up also. So I bought the fluid, 1 liter costs around 78,000 or 80,000, including this one. Approximate cost of the 55,000, all those things. Correct. In a big car, it may require half a liter to 1 liter fluid. Correct. Damper. At least half a liter. So you see the fluid alone, this much, that's why the damper costs 1 to 1.5 lakhs. It has electronic ECU, which control the current going. How it works? Based on, it measures how the vehicle is jumped, which is called sprung mass. Vehicle body is called sprung. They put a sensor, correct? Displacement sensor, accelerometer, which measures whether vehicle is moving up and down. If it is there, immediately it controls the voltage applied to this. Further, there's a ECU. Correct. So active suspension system is a mechatronic system in which the current going to coil is controlled, the magnetic flux is controlled. So finally the damping constant of the MR damper, we call MR damper. Generally they fix the stiffness constant. They don't vary. If you want, you can vary it, but much easy. Electronically controlled, this is easy. Correct. They call active suspension. So where the damping force of the damper is changed by controlling this one, but uses special magnetic field. We will see that when we talk about this. Right now, note on this point. So now the thing is non-adjustable movement. The damping constant by varying, I can say what rate the piston of the damper is moving. So vehicle sprung mass moving can be controlled, correct? Which is not possible in conventional damper. That's why it's a non-adjustable movement, all these things. Again, you spring stiffness also, you can vary this one, but you cannot do while the vehicle is running. Many times, this conventional machine use constant speed drives. Of course, engine is a variable speed drive. This one, forget it. Vehicle is, so we are talking mechatronic product, not only vehicles. We saw many examples. So mechanical synchronization, correct, using gears, levers, all those things. And because that means they add a weight, correct? As you add more number of mechanical parts, the system become bulkier, correct? And it requires complex mechanism. So it is not energy efficient. More weight, correct? More energy will be unnecessary weight will be sent. We call unladen weight, dead weight. Dead weight adds if you want to become more automation. Automation can be done with drive, correct? Gears, levers, and synchronizing mechanisms. So we had automatic gear transmission, all those things, even before mechatronic system, using, the fluid systems, correct? Hydraulic fluids and gears, all those things. So those mechanisms very bulkier. Now modern this one use electronic control, simple, correct? Transmissions, the gears, all those things can be quickly changed, compact this one. Then rigid, heavy structures, accurately determine tolerance of the mechanisms. How accurate you can do, because everything is mechanical. Friction, all those things problem. Again, it is fully manual control. These are the drawbacks of conventional products or this one. So if you go to mechatronic products, the system become compact. Simplified mechanism. Many things are now electronic control. Control system, all those things. Final actuator only is the solenoid, motor, all these things. Gears, all those things, everything is removed. Directly control. Correct. If you talk about electric vehicle, there's no gearbox at all. At the most, you may have a two-step gearbox. Generally, motor speed is varied. Correct. And the torque is controlled by controlling current. So don't need gearbox. So simplified mechanism. Gearbox is totally removed. Programmable movement. Then variable speed. Correct, to electronic control. Electronic synchronization. That means no gear links, all those things. The system will be compact, not bulkier. All these things are this one. And lighter structure, because as I told, as you remove number of mechanical parts, go for electronic system, subsystem control, all these things, the structure become lighter, the entire machine become lighter. As you gearbox, if you take a car, gearbox maybe is 50 to 60 kg, correct? If you remove the gearbox, you can save a lot of fuel. That's why electric vehicle can be advantages. Accuracy, accurate feedback, electronic control can accurately control with feedback mechanism. And finally, it can be a completely automatic programmable control. This is possible. Okay. So take down this point, important point, correct? So if you ask what is the advantage, disadvantage, mechatronics, this one, you are supposed to write this table. Okay. Then we will see that when we talk about mechatronics thing, again, this is a block diagram. I'm going to show one more block diagram. I have mechanical system with actuator built in. We are going to talk about them some examples. With the actuators controlled by electronic amplifiers, which we call power amplifiers. Correct. Many times the actuators are electric actuators. Correct. Of course, the engine is a mechanical system. It is going to burn fuel, generate. But controlling is an injector. Is a electromechanical. Injector is the actuator. It is electromechanical, which is controlled by ECU, give pulse width modulation. Correct? So, to drive the actuator, injector, you need power electronics. We'll see what is power electronics in afterwards, sense the amplifiers and filters. Correct? Then you need signal conditions, which you call amplifiers, all those things. Then you need ECU, electronic control unit, and you need sensors. Sensor cannot directly connect to ECU, so you need interface electronics, which is called as ADC and DAC. Correct? Analog to digital DAC, and of course you need software. All these things are the machine is really controlled by software. So you need a software model. You need a power supply because this is being a mechatronic, except the mechanical structure. Correct? All these things are electronic circuits. This one, so we need a power supply. The engine needs fuel. Correct? Which is a mechatronic system. Fuel is needed, but to control all the electronics, you need a power supply. So that's what it is. Okay, this is the functional block diagram. I will show you a detailed block diagram next convention. Then when we talk about the mechatronic system, we talk two things. One is control system. One is called open loop control, other one is called closed loop control. Correct? In open loop control, you have a machine. Correct? You have a machine. Okay, and the machine is controlled by electrical device, electrical actuator. This is my machine. Correct? Which is controlled by electrical actuator. Correct? Electrical actuator need to be supplied with specific the input. So the input is given by the controller. So, for example, you take a engine. Correct? In open loop control, I have the engine. Engine need to be controlled. Here we have an injector. Correct? That is the actuator, which needs to be controlled by a power amplifier, because you know the injector work generally 12 volt. The controller, for example, you have a open ECU, that is the electronic circuit. Electronic circuit, which is going to generate the pulse width modulation, which is supplied. Correct? Fuel pulses, we call it fuel pulses. The fuel pulses are generated by the controller, which in turn is controlled by the driver input, mechanical input. When you press the accelerator pedal, correct? So you are asking the controller generate pulse width modulator, that is given to the power amplifier. Power amplifier in turn is connected to injector. This injector is because the ECU develops 0 to 5 volt pulses only. The control system generally develop the most of electronic circuit work with that also if it is a digital circuit. Digital controller, this one, it will generate up 0 volts or 5. The output will be 0 or 5 volts only. No in between voltage. They call binary level. Binary level, that means 2 levels, 0 volts or 5 volts. Because the computer generates zeros and ones, we call binary number. The fuel pulse also, you want to open the injector, this is the injector opening period. Correct? This is off period, this is on period. The pulses are generated. The generator pulse will be 0 volts, 5 volts only. If I give to injector won't work. Inject one, then it will generate 0 or 5 volts. The current will be 0 or some say 10 milliamps only. Beyond that, the controller, the electronic circuit or ECU cannot develop more than 0 or 5 volts only, and the current is maximum few milliamps, 10 milliamps, something like that. That if you directly give to injector won't work because injector wants 12 volts and 3 amps or 5 amps, something like that, 8 amps, depending upon the the stroke length of the injector. Okay, that means the signal generated by ECU due to 0 to 5 should be amplified to 0 to 12 volt pulses. Same pulse, but only amplitude is increased. For that, what you need is a power amplifier. Power amplifier output is given to injector. Injector injects the fuel. Fuel is injected. Engine is running. We know that in open loop control, if I press the throttle, correct, 0% to 10%, if I press the throttle, what should happen is the fuel injection pulse, correct, will vary from 1 millisecond to, for example, 5 millisecond. Correct. Sorry, 0 is not possible because engine has to run with idle RPM. Generally, at least you have to idle RPM. You cannot drive your vehicle. Even to run the engine driver, you may do second pulses. So my pulse duration will be 1 millisecond. Correct. This is the period I inject the fuel. Fuel is injected every time. Correct. So next pulse, next cycle. So this is one cycle. A 4-stroke engine. I say 4-stroke engine. This is suction, then compression, then power, then exhaust. Okay, the 4-cycle mode. Again, suction, compression, power, again exhaust, then you will do. So this is engine cycle. Every time in the suction stroke, inject the fuel. Okay, I'm injecting for 1 millisecond. That develops, for example, few Newton meter that is sufficient to range overcome friction. Now, if I press the throttle, 20% throttle, I will open for 4 milliseconds. Fuel pulse will be, sorry, to 2 milliseconds, for example. I open for 2 milliseconds. Inject fuel millisecond. Then this is my suction stroke, correct? Then my compression, then power, then exhaust. So inject more time. Now, if I go to 75%, I open for 50%. For example, 3 milliseconds. Like that, if I go, this is 50% throttle, this is 25% throttle, this is 0% throttle, idle condition. I open 10%, my injection will be open for 4 milliseconds. Correct? And then again, next after 4 milliseconds. So this is how the engine is controlled. We call a pulse width modulation. Correct? Fuel injection will happen during suction stroke. How long injector open, that decide how much fuel quantity is delivered to the engine during suction stroke. So this is how the ECU works. Now, in concept open loop control, correct? So if I open my injector for 1 millisecond, correct? If I open for 1 millisecond, this is injection duration. The engine is supposed to run at from, for example, idle RPM 600 RPM. Correct? It should go to, say, for example, 800 RPM. Correct? It will go to 800 RPM. And during this, it develops very less torque. For example, 2 Newton, overcome engine just rotating. When you press the accelerator, 800 RPM, you open the throttle for, say, 10%. So it develops, say, for example, 5 Newton. Okay? That means if I open the injector for 1 millisecond, correct? And the output torque is this one is there. It is there. But you are not at all measuring. In open loop control, you are not measuring what is engine RPM, what is engine torque. And also vehicle speed, nothing you are measuring. Correct? You are not measuring engine speed, nothing. Now, if I open the injector for 2 milliseconds, double the period, I am supposed to go, for example, say 1200 RPM. I'm saying an example only, and develop, say, 8 Newton torque. Correct? And engine may develop, may not develop. Why? Correct? If I open this, you know the torque developed by the engine is proportional to fuel mass and, correct, mass of the fuel and mass of the air. Correct? So, mass of the fuel and mass of the air. That is going to decide AFR, air fuel ratio of the petrol engine, depends upon how much mass of the air was sucked in, how much fuel you are injecting. That is going to decide torque develop. Now, you develop this 1 millisecond, all these things because the mass of the air depends upon the temperature of the air, atmospheric temperature, right? Decide, and altitude where the vehicle is there, altitude, correct? Higher altitude, atmosphere density, air density reduces. When temperature increases, air density reduces. So if I suck 100 cc air, correct, at 30 degree, Mass equal to, I say mass of the air, sucked air under this one, say I say 10 milligram, correct? I am talking you weight or 20 milligram. And same air, if I say 100 cc engine at 40-degree temperature, the mass of the air will become 8 or 9 because air density reduces. Correct? So mass also reduces. Similarly, go to high altitude. But I am not at all measuring anything. Air mass I am not measuring. I am not measuring what a torque produce, nothing. There's no feedback. So that means if I generally expect, if I inject 1 millisecond duration injector open, I inject so many milligram fuel, engine RPM will go to this one, the table. But it's not going to happen. So this is called a open loop control. This is major drawback. Correct? To avoid that, what I do is I put a measuring device in this one, which measures the actual system output, engine torque or engine speed, some parameter which is related to airfield ratio. I measure and give the signal to the system. So the controller, it measures. See, you are saying inject the fuel for 1 millisecond duration. Sorry. So if I inject, engine RPM will be 800 RPM and 2 Newton meter, correct? And I put a engine's RPM sensor, and this is engine RPM, engine speed sensor, engine RPM sensor. I am giving to that. When I open the injector for 1 millisecond, engine is supposed to run at 800 RPM. But now it is not running because the amount of air sucked is the same, but temperature different, air mass is different because atmospheric temperature increase. Our vehicle is higher altitude. So the speed may be 700 or 750 RPM. Instead of 800 RPM, amount of the air is less. So when you inject fuel, that amount of the pressure, combustion pressure, temperature less. So the torque produced will be less. So the engine RPM reduces. So this is sensed by the feedback sensor that is given to this. So if I put 1 millisecond, engine is supposed to run 800 RPM, correct? But instead of now it is running only 750 RPM, correct? There's an error. This is called deviation, error. Error is nothing but 800 minus 750, which is 50. That means the controller knows that instead of person, I am putting electronic controller, which increases the fuel pulse to 1.2 millisecond. Instead of 1 millisecond, it increases because when I inject a 1 millisecond, instead of running at 800 RPM, running only 750. How do the controller knows? It measured using a sensor. This is called a feedback sensor. This is so now once the fuel is injected, now I'm going to open for 1.2 minutes, the torque become more, correct? Engine reaches 800 RPM. Why? I injected more fuel, correct? Because the amount of this one is different, air mass is different. Now, after some time, the temperature reduce, or your vehicle come down to from high altitude come to lower altitude. Then, if it's such same 100 cc air, the air mass will be what you have done 1 millisecond. So in that case, the engine speed will increase. So instead of 800 RPM, it go to 820 RPM or 850 RPM. Correct? So that is measured by sensor. So that means the error become minus 50. Correct? So that means you need to reduce fuel quantity. So the engine will reduce from 1.2 to 1 millisecond. So this is called auto correction. Correct? That is called a closed loop system. The new thing is this error amplifier and feedback sensor helps the mechanical system or any machine to maintain whatever the speed you wanted. What is speed you wanted? Which you call a set speed, a set point or set speed or reference speed. Correct? Reference point or this one. I said I run 800 RPM by injecting 1 millisecond fuel. That's what I commanded. But because of variation, engine is not performing when I open inject 1 millisecond, it goes to 800, instead 800, it goes to 850, sometimes it comes to 750 because the air temperature, all those things vary, the airfield ratio changes. So how do I know that? By using a feedback sensor, engine speed sensor. My interest is controlling the engine speed. Controlling engine speed is my interest. This is called a closed loop system. We will talk about closed loop control, proportional controller, proportional to PI, kind of PD derivative, all these things when we talk about control system. We will talk about 2 to 3 hours about that also. Any questions in this? Okay. Now, this is what called as automation. The main feature of automatic using closed loop control system. Open loop control system can be used, but it cannot find out any deviation in the actual working. If actual working deviates due to the environment condition, that cannot be corrected by open loop controller. In that case, you have to go to open loop. Many of the automatic control systems are using closed loop control systems. So where you need to have a sensor which measures a system output, and it is compared with the set point and error signal generated. Based on the error signal, controller develops the control signal. This is the control signal. Correct? This is a control signal. This is called as error signal. This is called as set point. This is called actual output of the system. Actual output of system. That by using sensor, feedback sensor. Okay. So that's how it works. The simpler, please note that this all thing we are talking electronics. You can implement automatic control without electronics. This was done long before. One such example, automatic water level control in your toilets, correct? So flushing tanks, automatic flushing tanks, correct? It is installed. There's no electronic, no sensor, nothing, but everything is built in. This is what this one. You can see that you have overhead tank, correct? Overhead tank. From the now there is a control valve. Please see that this is a control valve, the pivot with control valve. Now when there is no water, then you have a ball, correct? This ball is a vacuum inside. It is connected to a lever. Lever is connected to, this is the valve which can close. Okay. Now this is the tank. When there's no water, quickly I will complete. I know that already it is 5:50. In 5 minutes I'll complete. Then we can close this. Correct. So when there's no water, what is the idea of this whole system? Maintain water level up to this. This is the set point. Okay. Now, when you use your toilet, you will press a button which makes the water to go out. Okay. The water will go out. This ball will come here. It will be like this. Okay. So you can see that the valve is open. So the water from the tank will come and fill. The water level increase slowly. So what will happen? This is called a float, hollow ball or float. The float will start moving up. As it moves up, you can see that this will become like this. When the ball comes like this, this will become like this. When the ball comes to this level, you will see that it's fully closed. This is the closing valve, inlet valve. It is completely closed. Water is reached. So no more water can come. So level is maintained. Again, you flush it. What you do that? The water goes out. Again, the ball comes down like this. So this is the example for automatic. But you can see that all these things are used with mechanical lever. All this very simple control. Correct. So this is what we are talking. So the automatic level, you can see here. This is the water level. The whole idea is maintaining water level up to this. Correct. So when the water level goes down, the valve is open. Correct. The correction unit is nothing but this valve. This is the correction unit. Correct. This is the valve. The valve is controlled by sensor. Who is the sensor? This ball is the water level sensor. This is the sensor. This is the actuator. The lever with this one is called, the valve is called as actuator. Correct. And the whole idea is maintaining this constant water level without overflowing. Correct. This is how it works. The pivotal lever is a control unit. This rod which is connected to the ball. The whole thing is called as, the lever only is called as control unit. It is a mechanical, simple lever works as a control system. Correct. So this is an example. Take this. This is the last slide. Correct. So if you are asked to write the functional block diagram mechatronic system, please draw the functional block diagram and explain various parts mean. You have to draw this one. I may stop it here. Maybe next class we will start, continue with this. Okay. Can I stop here?
Yeah, okay.
Okay. See you on this one. We missed one. When is our exam? Any idea?
20th, sir. 20th of October, sir.
Today is 18, no?
Sir.
So we have 3
This
classes.
month another 3 classes is there. Next month another 3 to 4 classes will be there, sir.
Yeah. Yeah, this month 4 classes, 23rd, 24, 25 and 30. Correct? Next month we have Tuesday 1 class. Okay.
So
Is
another
that
8
9th?
classes is
9th or 20?
20th, sir. 20th, sir.
No issue. Okay, fine. So next class Monday will meet. Okay.
Thank you, sir.
So almost this is last slide for this one introduction. Then what we are going to, I will just quickly tell. We will talk about modeling this mechatronic system. Correct? I told you mechatronic system main thing is modeling the mechanical. So how to model, how to write mathematical model of simple systems. We are going to discuss through at least 3 to 4 classes. Then we will talk about sensors. 3 to 4 classes. Then we will talk about actuators. Correct? Actuator forms. This will be at least 3 to 4 classes. Then we will talk about the amplifiers and signal conditioners. Correct? ADC, DAC, this is 3 to 4 classes. Then we talk about embedded controller and what is the control software, how it works. 3 to 4 classes. Correct? So I wanted to complete mechanical modeling, sensors and signal conditioners before the midsem.
Okay, sir.
We will complete that. We have sufficient class. Each will be 3 to 4 classes. I will explain systematically. Then this portion will be covered for midsem exam, including what we have covered till now and also this one. Okay. See you on Monday.
Right.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Have a nice weekend.
Thank
See
you, sir.
Okay.
Thank you, sir.